Hi, sixth graders. We're on lesson 6.3, which is rate of change. So make sure you label your page appropriately. The learning target is being able to identify rate of change and slope using tables and graphs. So rate of change is a rate that describes how one quantity changes in relation to another. So this would be important to write down, as well as change in y over change in x, which you're going to hear me say a ton of times in this video and over in class and as we're working on rate of change. So change in y over change in x. So this is like as a fraction. So if we're given this data in this table, water level loss, and after how many weeks, the amount of water that has been lost. So what we do is, so if you can recall, this first column is our x, and this second column is our y. So if we were going to plot these points on a graph, because we could, our ordered pairs would be 1, 1.5, 2, 3, and so forth. So the way that we figured out the rate of change is we find the difference in all of the y values and then all of the x values. So the difference from 1.5 to 3, so we would take 3 minus 1.5 and we get 1.5. 4.5 minus 3 is 1.5. And then 6 minus 4.5 is 1.5. And then we do the same over here. And as we can see, 2 minus 1 is 1, 3 minus 2 is 1, and 4 minus 3 is 1. So now what we do, we take our change in y, which always is going to be the same. So it's 1.5 over our change in x, which is 1. So we're going to include our units, 1.5 centimeters, and then 1 week. So this tells us that whatever it is losing 1.5 centimeters per week, or 1.5 centimeters of water per week. So then we could rewrite it. Our rate of change is 1.5 centimeters per week. All right, so we're going to do the same thing with time and wage. So here, our change, we can see from 0 to 9 is 9. 9 to 18 is 9. 18 to 27 is 9. And then here, again, we're going up 1, 1, and 1. So we have $9 over 1 hour, which can be rewritten then as $9 per hour. So the rate of change is $9. Well, the rate of change is $9 per hour. It's telling us for every hour this person is making $9. Cars washed, so the number of cars washed and the money. So again, we have X and we have Y and the money made. So this time we're going up by 40. And as you can already see, and you probably are figuring that it's the same. And then this time our X's are increasing by 5 and 5 and 5. So we take our change in y, which is 40, and then we take our change in x, so it's $40. Our change in x is 5 cars. We want to find our unit rate, or we want to find the rate of change for 1. We want to get it down to 1 in our denominator. So 1 car. So remember, we're going to divide both our numerator and denominator by 5 to get to 1. So 40 divided by 5 is $8. So our rate of change is $8 per car, or 8, you could even leave it as 8 over 1, but 8 for every car, this person or whoever made $8. And we are going to skip that one and go on to our graphs. So now if we're given a graph, it's just a little bit different, but we can still find the rate of change, and we still want to look for change in y. Let's make that a better h. Over change in x. So super important to remember. Change in y over change in x. So y is always on the top. So when we're given a graph, we need 2 points. And we can see with each point we have an x value and we have a y value. So the change in y, so what I'm going to do is I'm going to take this point and I'm going to take this point. And I'm going to take my 2 y values and I'm going to subtract them. Gosh, I'm having issues with making an 8. 18 minus 9. And then I'm going to take my 2 x values and I'm going to subtract those. 2 minus 1. So if you had this in a table, we had all of our x values and all of our y values in a table, we would be doing basically the same thing that we're doing, it just looks a little bit differently. So now we have 18 minus 9 is 9, and 2 minus 1 is 1. So our y, so this is our x, and this is our y. So it's telling us that it is $9 per shirt, which makes sense. For 1 shirt, it is $9. 2 shirts, it's $18. 3 shirts, it's $27. So it's super important to know that when you subtract your values, you have to go in the same order. So see how I took 18 and I subtracted 9, and then for my x's I took 2 and I subtracted 1. If I wanted to do it the other way, you don't always have to go in that order. You can go 9 minus 18, but then I have to do 1 minus 2. So notice there's the y's on the top, the x's on the bottoms, but then vertically each of our ordered pair, the numbers from each ordered pair lines up. So we'd have negative 9 over negative 1. A negative divided by a negative is a positive, so we would still end up with $9 per shirt. If you flipped this around accidentally, you'd have negative 9, but then if you had 2 minus 1, you'd have positive 1, and then you would have negative 9, and then the answer would not be correct. So it's really important to keep it in that correct order. So for this graph, we have the height of the ramp. So for access ramps, the height of the ramp is x, and the length of the ramp is y. So we're going to pick 2 points. So we can pick this point and this point. So what we do is we take our y values, which is 144 minus 72, and then we have 12 minus 6. And just to double check, 144 and 72 are my y values because they're the second number of the ordered pair. 12 and 6 are my x's, and then 12 and 144 should line up, and 6 and 72 should line up. And they do. So I have 144 minus 72, and I get 72. 12 minus 6 is 6. We want to get 1 in our denominator. (72) divided by 6 is 12. So the top number is our y. So this tells us that for every 12 inches of length, there is 1 inch of height. So it's the same unit, so it's a little bit confusing, but it's but then we have to look at what our y and our x are telling us. So for every, or we could say for every inch that it is high, it's 12 inches long. So if you think of a ramp, that would make sense that it's longer as it goes higher. Okay, so slope is the rate of change between any 2 points on a line. So slope is basically the same as rate of change. So we're given this table, and it shows the relationship between the number of seconds y it takes to hear the thunder after a lightning strike and the distance x that you are from the lightning. So if we're given a table and we want to find the slope, we are going to graph it. So remember, these are our x values and these are our y values. So these are our ordered pairs. So 0, 0, and then we have 1, 5, 2, 10, 3, 15, 4, 20, and 5, 25. So the slope, this should be a fraction, is the change in y over change in x, which basically is the exact same thing as the rate of change. So what we're doing, or what they did in their example, is they used these points, 210 and 525. So they took their y, they subtracted their y values, 25 minus 10, and then 5 minus 2. So it's 15 seconds, because remember, this is y, and this is y, this is x, and this is x. So 15 seconds for every 3 miles. So then we simplify, and it's 5 seconds per mile. So it says for every 5 seconds between a lightning flash and the sound of thunder, there is 1 mile between you and the lightning strike. So because you're going to hear the word slope, I just want to make sure that you understood how to find the slope, which is basically the same as rate of change. And we are going to skip that last table there. And so I want you to make sure to log into NICU and take your 6-3 quiz. If you need to rewatch or look at more examples in the book, feel free. And make sure that you have your math notebook for class tomorrow. Have a super night, and I will see you tomorrow.